Where have you been?
Let's try to go.
Oh, you and your water. You're mad for being hydrated.
Oh, I want to. It's
Now, to get started, well, not right at the start, but you will need your calculator for this lesson. Has anybody seen this symbol before? Looks like an well, it is an exclamation mark, but do you know what it is in maths?
Yeah.
No. Yeah. You say this is n factorial. And this is what it means. For example, 3 factorial, what would that equal? 3 times 2. Okay, so some of you know this. This is 6. 2 factorial, which is 2. 1 factorial, 1. 0 factorial, which? No. Peter's going to tell me. 1. Yeah, so 0 factorial is 1. Now, can you just take out your calculator and find the factorial button on it?
yeah.
You found it?
You don't have it.
No, you have it. Did you find it? Yeah? Yeah? Okay. You all found it on the calculator?
That's okay.
Okay, that's okay. Can I scroll down? Yeah. So, next. Has anybody seen this before? NCR. The formula for NCR is n factorial over r factorial n minus r factorial. So, for example, 5c2 will be 5 factorial, 2 factorial times 3 factorial. Okay? Top bottom difference. Yeah? Now, you don't have to type this all in on the calculator. Again, what's nice is your calculator has this button on it. Can you find that button on your calculator now? It's sometimes above the multiply, or did you find it, Bello?
Yeah.
Can you type in 5c2 on the calculator? You typed it in? Yeah. And what did we get? 10. Yeah. Okay, so I'll give you a few to calculate before we continue. I want you to calculate for me using the calculator 5c0, 5c1. No, you didn't, it's right here. 5c2, 5c3, 5c4, 5c5.
What's this?
1, 2,
First one is 1.
1, 5, 10,
Last one is what?
10, 5, 1.
Looks familiar? Where have we seen this before? Yeah. This is row 5 on the triangle, isn't it? And this basically gives us, roughly speaking, our result, which is called the Binomial Theorem. Now, I'm just giving you a rough version of it. The Binomial Theorem says that row n will equal nc0, nc1, nc2, etc. until ncn. Basically, you can use this c function to calculate the coefficients. Why is this a good thing?
You don't need to write the triangle.
You don't need to write the triangle now. That's useful, isn't it? Yeah. You need a bit to the left, is it like that?
Like the light.
Will we is it from the light or from the window? Maybe if we close the blinds?
Like low down.
All the way maybe? Or no? Fine? Yep, okay. Alright. Can we scroll down? Yeah. Let's practice using the binomial theorem now. Okay, so scrolling down. Using binomial theorem, let's expand, let's say x plus 2y power 4. So what we do now, what row do we need? 4. 4c0 x2y plus 4c1 x2y plus 4c2 x2y plus 4c3 x2y plus 4c4 x2y. Okay, and now the powers. Let's start here with 0, 4, 1, 3, 2, 2, 3, 1, and the 4, 0. So what's 4c0? That's 1, 1, 2, 4, 16y4. Okay, 4c1 is 4, 4 times 8, isn't it 32? 32xy cubed? Okay, what's 4c2? 6, 24. X squared, y squared. 4c3 is 6 again, is it?
Yes.
Yeah? 12x cubed.
No,
No, it's not?
3, yeah.
It's 3.
Yeah.
So 6x cubed y. And then the last one is x4. I think we did all the calculations right there. Yeah, is that okay? 4c3 I was told is 3, but it's not, is it? You're right, it's 4. Who told me 3? It should be 4. So that should have been 8, is it?
Yes.
Okay. Okay, you got that? Let me give you a quick one just to practice before we do more. I just want you to quickly expand this using the binomial theorem. No, be careful, you start at 0, 3C0.
First with 0.
Yeah. Do you have answers yet, Mary? No, don't put the minus on the outside, put it on the inside. So change the minus to plus and put the minus on the 3 in the bracket.
Okay.
Do you understand what I mean?
Yeah.
No. Put the minus in the with the y, beside the y. Like this, look. 3c0, 2x minus 3y.
Okay.
Yeah. Right. Do you have the answer? Maybe. Well, what's the first one? 37? 27 y cubed. All agree? Yeah. And then the next one is a plus.
54 x y squared.
Yes. Yeah. Minus.
Minus 36 x squared y.
Good. And finally,
X cubed.
good. Good. Now, is this okay? Now, what's nice about this theorem is it actually lets you jump to any part of the expansion. Let me give you an example. So suppose I have something like, I don't know, 2 plus 3x power 5. And I don't want you to expand the whole thing, okay? I might say, what is the x squared coefficient? Meaning, I just want you to give me the number that goes on the x squared. Do you understand what I want? As an example. Yeah. So, you got the idea there, Marwan. We know that there'll be a c in it. And we know that this number up here will have to be a 5. Now, we'll know that there'll be a 2 here. And we'll know that there'll be a 3x here. But I don't really care about getting the x, because I just want the number part. Okay? Now, we have to think very carefully. What power must go here? Why? You want the x squared part. Therefore, what power must go here? 3. Now, you might have noticed the shortcut if you look at the examples we've done, or maybe someone can tell me. How did you figure out quickly that the other one is 3?
5.
Yeah, okay. Or as I would say, the total here must be 5. Because it's the power 5. Yeah? Yeah? What goes here, though? Or is it 2? It doesn't matter, correct, fellow. You caught my trick. It doesn't matter. You can use 2 or you can use 3, you'll get the same answer. Okay? So, 2 here. So the coefficient will be 5c2 times 8 times 9. What's 5c2, please? 10. So 720?
Yes.
Yeah.
Now please be warned. In the exam, if you write 720x squared, you will lose a mark. Why? They ask for the coefficient of x squared. Now, what would they need to ask for if they did want the x squared? They wouldn't use the word coefficient. What might they say instead? No, because we're not finding the value of x here. Yeah, more mathematical word than part. No. Huh? Yeah, but I'm saying this is wrong. It should be 720. That's right. But what would they need to say so that the answer would be 720x squared? Term, that's it. If they wanted the x squared, they would then say, find the x squared term. If they only want the number, they would say, find the x squared coefficient. Okay? Coefficient is just the number. Term is the number and the x. Are you all right with that vocabulary? Yeah? Right. Can you write that down? We'll do another example. So actually, let me just make note of who I'm missing today. Can I borrow your pen or a pen, Abdul Rahman? Thank you. So who am I missing? Ming? Just Ming?
I think so.
Yeah, just Ming. Okay, thank you. Jeffrey's here.
Yeah.
All right, can I scroll down? Yeah? Right. Let's see if you can figure out what to do here. I want you to expand up to x squared in ascending powers. Do I want you to fully expand here? No. I want you to expand until you get what? X squared. Now the next part is important. Do I start at x power 5 or do I start at x power 0? Why? Ascending powers means the power should increase. So when you expand this, how many terms will you have here? How many? 3, won't you? The first one will be a constant. The second one will be linear. And the third one will be quadratic. Yeah? Okay, I think you can do this. I hope you can do this. So give me the 3 terms here. I'll get you started. The first one will be 5c 0, 1, and then minus 2. Minus 2x. And this power must be 0, and this power must be 5. Okay, so you give me the next 2. Right, you got it? The first one is 1.
Yeah.
Minus, what's the next one?
Minus
10x, very good. Plus 40x squared minus dot dot dot. We stop after the x squared. And we stop at the x squared. Okay? Is this straightforward? English time, if we wanted to start with x power 5, we would have said what? Descending. Descending. Ascending, descending. This should remind you of some vocabulary from physics. Does it remind you of any vocabulary in physics? Think of a word that begins with A, that means goes up, and then begins with D and means goes down. Acceleration and deceleration. Ascending and descending. Yeah? Okay? Now, let's do one more example, but now a hard one. So I think, Marwan, you were asking me last week, are there ever questions where there's something missing? Like you don't know a number, wasn't it?
Yeah.
You don't know the power or you don't know the 2 or something. So that's what's next. I tell you that px plus q power 5 equals x power 5 plus 15x power 4 plus 90x cubed plus dot dot dot. And my question is find P and Q. Now, before we do that, any ideas on what we could do? What could we do first?
Equations from the first and second term.
Yeah.
Yeah, so what do I do?
Like the term 1,
Which term 1?
x power 5.
Yeah?
It should be c.
Yeah, okay, I think you got it. So on the left, you should expand on the left. Or like what you said, you can compare it. What you need to do is expand here, and then you can compare the x5 term on the left should equal the x5 term on the right. So for example, the first one here on the left will be 5c0 px power 5 q power 0. That's the first term on the left, isn't it? What should that equal?
5, 4, x
Well, it should equal the 1.
Oh, yeah.
I didn't. Oh, I should. Yeah, let me get rid of the x there. I'm just looking at the coefficient. Okay. What can this equation tell you? What value can you get from this?
P is 1.
You can get the p. Yeah. Can you get the q? No. No. So we already have the p. Great. So now how can we get the q?
The second term.
We can look at the second one. Okay, so let me just write this one down. This will be P5 equals 1, so P equals 1. Okay, let's look at the next term. 5C1. What's next? P, but we know P. What is this? 1. So that's 1x. I'll just put the x in. Power 4 Q 1.
Teacher, this is not transfer the negative one.
For this one?
Yeah.
No, because the power is 5. It
Okay.
can only be positive. We have this issue with the next one. What should this equal?
15.
15. Yeah? Yeah?
q is equal to
Correct, because 5C1 is 5. So then this gives us, so Q must equal 3.
So, Q plus 3.
Yeah. Not too bad. In fact, it's so easy, I have students falling asleep. Too easy for you, huh? You should be wide awake now with all your water. No? Okay.
The x is not necessary, right?
Yeah, we're just looking at coefficients.
Let's say
Hang on. One at a time, one at a time. Son, then Bello. Yes?
How can I calculate to the Q equals 3?
Q equals 3? What do you mean? Oh, how did you get Q equals 3? Yeah, well, what's 5C1?
Yeah.
It's 5. What's 1 power 4? 1. 5 times 1? 5. So really, what you have here, son, is 5Q equals 15. That is 5Q equals 15.
Okay.
Yeah, Bella, what was your question? That was your question too? Okay. 2 questions with 1 answer. Great. Alright, did you write that down? Do you all have that? Yeah. Let me give you just one more. That's kind of like something I saw in the exam. make it different. The coefficient no, how do I say? The x squared coefficient in this is 720. Find p. So I tell you what the coefficient is supposed to be for x squared. It's supposed to be 720. So you tell me what the p should be. Two, I think, yeah. Is there any chance it could be minus 2 or just only plus 2? Only plus 2. So what is the coefficient here? It will be 5c2 p cubed 3 squared. That's the coefficient, isn't it?
Yeah.
And that should equal 720. So I think you rearrange this and you get p cubed equals 8. So p equals 2. Guys, is that okay?
Yeah.
Are you sure?
It's just, I have a question.
Yes.
I returned out.
What's the question?
Because I don't know where is the answer. Right here is a 3, here is 2.
In this one?
Yeah.
Yeah, because I said the x squared coefficient.
Yeah, but if you open to the p plus 3, x is different. P
Yeah.
P equals 3x.
P equals 3x.
Yeah.
P equals 3x.
The 5c2 p equals 3x. How can I choose?
The 5c2. Okay, hang on. Is the 5c2 okay?
Yeah. This
Fine.
is-
Oh, okay, fine. Is the p cubed okay? No.
No.
The cube's not. Is the 3 squared okay?
No.
No, the square is not.
Yeah.
Okay.
I don't know.
So what is beside the 3? It's x, isn't it?
Yeah.
And if I have a square here, then this will be 9x squared. And I only want x squared.
Yeah.
If I put a different number here, will I have x squared? No.
No.
No. I need x squared. So I must put 2 here. If I put 2 here, this forces this one to be 3.
Okay.
Why must this be 3? The total must be 5.
Okay.
Yeah. Is it? You don't look okay. You look confused.
Okay, I'm not confused.
Are you sure?
Yeah.
Can I trust you?
Yeah.
Okay, great. I don't want to. I trust him. I trust him. If he tells me he's not confused, he's not confused. And anyways, we'll have a tutorial tomorrow, so we can do more of these in the tutorial if you need to. Yeah? And if Ming is not here tomorrow, we'll do her question that she asked last week, okay? She can watch it on the video later. We have a maths tutorial tomorrow, don't we?
Yeah.
Right, let me give you your homework. You can do it for a few minutes before we start the next lesson. I'll just keep it straightforward. I'll say homework is 1A, 2A, 3A, 4A, and 5A. And this one is, I'll tell you now, very hard. Very hard.
Tutorial.
Perhaps. Hmm?
I never learned that before.
Really?
Yeah,
Interesting.
I never learned that before.
No, he's done maths before, I'm sure, but just not this lesson.
Oh.
Have you done this topic before?
2 years ago.
Yeah, just the binomial x. You know, Father Maso.
Okay.
I've never done this before.
The binomial theorem? Yeah. Did you do Pascal's triangle?
Yeah.
Yeah, okay.
I did it in primary school.
Yeah.